Welcome to the Brainiac Academy, and this is Surgical Medic on your screen. So let's go into calculations under gas laws, and these are the laws under this thing. These are things you need to know. So there are some of my guys, the boys, the Charles, Avogados, Grams, and all of them. They were the one that actually um brought about all these things. So that's why we need to, we as a students, we need to actually learn and understand their concepts. And JAMB always bring questions a lot from this aspect of chemistry. So now we'll be looking at I think here we'll be looking at Boyle's law, Charles' law and its calculation, then the general gas law. That's what we'll be looking at. The Boyle's law, then we look at the Charles law, then look at general gas law. So we'll look at the calculation under these things. So in the next video, so we'll look at the rest. Let's ensure we follow closely. Boyle's law, Charles law, general gas law. So we'll be dealing with the calculation part, calculation in chemistry. So alright, Boyle's law. So what this my guy was actually trying to explain or trying to prove to us is relating our PV. I explained this in the last Telegram class, the last class in chemistry. I explained what you used to be remembering. Use PV. So PV. So when you know your PV, or let's say your vice principal, let me use the second marker. So let's say maybe you are using your PV or you are using VP. So your vice principal in your school. So very simple. Is it that you use this or use this? Now, if I'm using this, I can actually define my Boyle's law very fast, even without looking at my book. Do I need to look at my book? No. What I will do is that the pressure, are you with me? The pressure of a given mass of a gas is inversely proportional to the what? To the volume. Are you with me? The pressure of a given mass of a gas is inversely proportional to the what? To the volume. Are you with me? Or you say the volume of a what? Of a given mass of a gas is inversely proportional to the what? To the pressure. I don't know if you hear that. So that's the scope. And here, temperature would be constant. Temperature will be what? So that's why mathematically we can have it as the volume of a given mass of a gas is inversely proportional to our pressure. Sure, you guys get where temperature is the constant. Are you guys with me? So now we now have our V, which is equals to what? Our constant K over what? Over P. Very simple. Meaning that if we cross multiply this, K will be equals to P times what? Times V. Alright, so that means our K is equals to P what? V. So if you want to calculate anything at all under Boyle's law, the constant is PV, meaning that your P1 V1 is equals to your P2 V2. So here, constant is PV, meaning that your P1 V1 is equals to your P2 what? P2 V2. So this is just what you need to know. Very simple under Boyle's law. Then use this mathematical expression, this mathematical formula, use it for any calculation at all under Boyle's law. Are you with me? Now, I think you should know the graphical representation. You have to know this too, because you just see it in the option. Yeah, they will ask you which one is illustrating Boyle's law. You need to know it also. How will I know it? What I will look for is my VP in the option. I will look for my VP or my PV. If I'm using VP, that means the graph will look like this. I think let's use our red pen. I have multiple this so that learning will be fun. I like learning. It should be fun. Alright, so yeah. Okay. Our graph. Alright. So I want to use my VPO. So that means my V here is in what? Meter cube. Meter cube is coming from length times breadth times height. Check it to give us our volume, to give us the units meter cube now. Then the pressure here, that means volume is inversely down. You have your 1 over P here. Your P will be in pressure is measured in what? So the meter. So now the inverse proportion is telling you that it's the kind of, how will I put it now, that it will start from here, like from the origin here, then move like this. I don't know if you guys get it. So that's that about the law. Like, can you guys see this thing very well? Like a straight line graph. That's for VP. Now let's do for our PV. Let's do for our PV. If it is PV, you are plotting graph of P against V. This thing will be like this. Then if your P is here, then you have your 1/V here. This one will be in meter cube. It can be in centimeter cube, or let's but this the standard one, the accepted one is meter cube. Then here you have your millimeter mercury. Then the graph too will still be this type also. So to move from the origin here. That's Boyle's law. Then there is still another one. Let me clean this board so you can understand this very well. Let's clean this board. The third graph, this is how it looks like, and we are using the VP for it. So coming like this, going like this, then you have your VP. So the volume of a fixed mass of a gas is inversely proportional to the what? Pressure. So those are the three graphs you should know. Very easy. I think this is all you need to know. Let's just quickly go into one calculation like that under this Boyle's law. Let me clear the board for you guys. Question 1 under Boyle's law. It said 375 centimeter cube of a gas. Alright, it said 375 centimeter cube of a gas. And this thing you need to know, this one, the unit of volume is what? Your centimeter cube. The unit of this is millimeter what? Mercury. These are things you would look for inside questions so that you can know, okay, millimeter mercury, that's my pressure now. Okay, centimeter cube, that's my volume now. So these are things. Then your temperature, if it's temperature is not involved here, please, because temperature is constant. So take notes. If it's temperature, you'll be looking for your what? Your Kelvin. They will give you in degrees Celsius rather, degrees Celsius, but you convert. That's plus 273. That's how you arrive at your Kelvin. And so don't worry, when we get to Charles' law, you understand this better. So don't let me confuse you. Alright. So here the question says 375 centimeter cube of a gas. 375 centimeter cube of a gas is actually telling you that is your volume, centimeter cube now. So your V1 is 375 what? Centimeter cube. Let's continue the question. Let's say, and has a pressure of 770 millimeter mercury. Millimeter mercury here is telling you that is your pressure. So 770 millimeter mercury is our P1. Let's look at the next parameter. It said find its volume. So we are looking for the next V, which is our V2. That's what we are looking for. Alright. If the pressure is reduced to 750 millimeters, so that the second pressure is now 750 millimeter mercury. How do I know that this is my second pressure from millimeter mercury? Very simple. Then you look at it now. This question is only P and V. Only my VP and T now. VP and PVK. Wow. Boyle's law, sharp. This thing is simple. Even primary 1 students will quickly solve it. P1, P1, P2, V2. Even primary 1 students will solve it for you. Your P1 is what? 770. Your V1 is what? 375. Your P2 is what? 750. Then your V2 is what we are looking for. Then you now begin to solve. 770 times 375. Check your calculator. What's that one giving you? Then what you now do here. So this one we have 750 times V2. So you put your hand on what? On V2. Then you divide by the one at the back of what you are looking for. I don't need to explain this one now. You know this one now. So this one will be over 750. Then if this one cancel this one out, we get our value of V2. So V2, which is equals to this one times this one, you press it on your calculator. Then you now divide by this one. Then you get the answer of V2, in which the final answer should be 385 watts. The unit of this should be what? Centimeter. See, you guys, let's clean the board. Let's go to the second question. I think we should just let's move to Charles law like that. We don't need to dwell on this. We don't need to dwell on this too much. So you guys should try multiple questions. Understand something. Before we move to Charles law, this part, Charles law, we need to like understand temperature conversion, because if temperature is to be in that question, you have to check if it is already in Kelvin or maybe it's in degrees Celsius. This is it. We have our temperature conversions. Now, if it is in degrees Celsius, if it is in degrees Celsius, you have to convert this degrees Celsius to Kelvin. How will you do that? That means that thing in degrees Celsius plus 273 will give you your what? Your Kelvin. So let's now assume that they give you 40 degrees Celsius. That will be your convert 40 degrees Celsius to Kelvin. What will you do? Just add your 273. Just know your 273. So that's your 40 in degrees Celsius plus your what? 273. Then you add it. So I think that's that. But if you want to convert back to Celsius, for example, now let's say, let me clean this. Okay, if you want to convert back to, okay, this thing is in Kelvin already. You can now say convert 400 Kelvin to Celsius. What will you do? That will be your 400 minus 273. Then the value will be your value for what? Degree Celsius. That's that. Press this on your calculator and you get your answer. So let's quickly go into Charles law. Charles law. Pause. Right, let's go into the second list, which is the Charles law. The Charles law. So the Charles law here now, Charles law is actually stating something, and this one is your VT. That's your VT. So it was actually telling us that the volume, all right, of a fixed mass of a gas is what? Directly proportional to the what? The temperature. I don't know if you guys get the volume of a fixed mass of a gas is directly proportional to the what? To the temperature, provided that the pressure is kept constant. So if the volume is directly proportional to the temperature, what would be constant? You already know now, PVT. If T is constant, then your V will be your PV will be either inverse or direct to each other. So if this one is proportional to this one, that means our pressure is constant. Sure you get. So the volume of a given mass of a gas is directly proportional to the what? Temperature. So mean that our V is direct to what? The K of T. I don't know if you guys get this thing. So now let's now divide. So V, which is equals to what? KT. So you divide by the coefficient of T. All right. Are we? Yeah. Are you guys getting this thing? Mean that our K is equals to V over T. So that's that under Charles law. And this thing is actually trying to tell you that your V1, all right, over T1 is equals to your V2 over T2 equals to your V3 over T3 equals to your V4 over T4 blah 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 V over T infinity. Sure you guys get. So that's that. Because of your level, let's stop there. Let me clear the board. Right. The graph, you need to know this graph because you don't always see questions. They will ask you this thing is illustrated by this thing above is what. Then you gotta check your option that okay, which one represents Charles law here. Then you begin to check. This is how you would know. This is under Charles law. We have our V is directly proportional to what? T. Now the graph would always be V against what? T. That's the very first thing you go and check under that option. That okay, I will have to check okay V to T abi, that's the volume of a fixed mass of a gas is directly proportional to what? The T. Are you guys getting it? Now that means that it's going to be a straight line graph, that is passing from here to here. That's that. And this one will be in what? In Kelvin. It must be the absolute temperature in Kelvin, while this will be either in centimeter cube or what? Or meter cube. So that's the first graph. Let's check the second graph. So that this one is actually the one that will actually show that temperature scale. Meaning that from the thing is coming from here, cut across here, then you now trace from here down, trying to tell us that this place is minus 273. Then this is your origin, normal 0. Then your V in centimeter cube. I don't know if you guys are getting the logic. This will be your T in Kelvin, normal. So these are your graphs under Charles law. Let me clean the calculation. This will be our question 2, and this calculation will be coming from Charles law. Now the question says at 17 degrees Celsius. So this one is actually starting from your temperature value, and they gave you what? 17 degrees Celsius for your temperature. So T1 is 17 degrees Celsius. And what do I tell you under gas laws? I told you, if they give you temperature in degrees Celsius, immediately convert. And how do you convert to Kelvin? That is, you just add your 273 K, so which is equals to what? Let's leave that one. Just you guys should press your calculator ahead. Let's look at the rest parameter. They said a sample of hydrogen gas occupies 125 centimeter cube. That is our V1. Our V1 is what? Our V1 is 125 centimeter. How do we know this is our V1? From the unit, I can see that this is my length times breadth times height, which is in centimeter cube. So definitely this is my volume, and it's the very first volume they gave me. That's my V1, which is 125 centimeter cube. What will now be the volume? So is it that what will now be the what? The volume. That means I'm looking for the second volume. Very simple. At 100 degrees Celsius, so they already give us the second temperature. So the temperature becomes 2, which is our 100 degrees Celsius. And I told you that if this temperature is in degrees Celsius, what will you do? So what you would do is you would add your Kelvin, that's plus 273 Kelvin. Press this on your calculator ahead so that we can put the value soon. So they said if the pressure remains constant, they even give us expo already, because Charles law said pressure is constant. Now you get now from our BT, let me use, the volume of a given mass of a gas is directly proportional to the temperature in which the pressure is constant. So inside that question too, they said that pressure is constant. So meaning that we are going to go to our Charles law formula. And what's the formula? Very simple. So looking at what they gave you guys is VT. So that would be V1 over T1, which is equals to V2 over T2. I think from this, you guys should be able to solve. But let me assume I'm teaching a primary 1 student. So V1 is 125 centimeter cube. So my 125 divided by my T1, which is what's the value of this one? What do you guys get? 117 plus 273, that's 290 Kelvin. Put it there, 290 Kelvin, 373 Kelvin. So now, so let's go back to what we are doing. So V2 is what we are looking for, divided by your T2, which is 373. Then you do your normal mathematics now, just cross multiply here your V2 times this one, that's this V2 times 290, which is equals to this times this, that's 125 times 373. So what will you do here? So you divide by the coefficient of this one, and that's what you are looking for. You leave it. The one that is beside what you are looking for, you put it down. 290. Then you cut. Pam pam. Don't forget to put it under here too, shall. So your V2 will be what? Press your calculator. Let me see what you get. Press your calculator. That's 125 times what? 373. Then your value divide it by 290. Then you should get 161 centimeter cube. So if you did not get this, that means you did not press your calculator well. Let me clean the board. Now we are dealing with this one now. General gas equation. Here there are things you need to know. General gas equation. Actually, this one is trying to it's not even trying, he did it now. He combined both Boyle's law and Charles' law together. What's your Boyle's law now? Your PV or VP? So normal. The volume of a given mass of a gas is inversely proportional to the pressure. So but your T here is what? Is constant. Sure you get. But under Charles' law, we have this is our first equation, sha. Now Charles' law says that one is your VT now. So the volume of a given mass of a gas is directly proportional to the temperature, meaning that the pressure is constant. So this is your equation 2 like that. So what general gas did was that it combined, like it was from the combination of both Boyle's law and Charles' law. Sure you get. So that means your V is proportional to 1 over P, sure you get, and also proportional to our T. And then from here we know that our PV over T is equals to what? Constant. So and then from here you know that your P1 V1 over T1 is constant. That's P1 V1 over T1 would always be equals to the P2 V2 over T2. So let's try to write it out normal. Sure. So P1 V1 over T1 is constant, meaning that it will reoccur again. P2 V2 divided by T2. I don't know if you guys are getting this thing, but there is such a thing as standard temperature and pressure. Let's understand that before we go into the calculation. So please, you have to check if you see any question and this one is stated inside that question. That means that you are to use your number 6 and use the standard unit or standard value of this thing. Now what do I mean? This is standard temperature and pressure. And what's the unit of your standard temperature? The unit of my standard temperature is 273 Kelvin. So if they did not give me 273 and they mention in that question that STP, just know that you take your temperature as 273. You take it from heaven as 273. Then your P is what? Your P is 760. But this 760 is in millimeter mercury. But inside that question, if your second prayer is not in millimeter mercury, maybe your second prayer is in Newton per meter square, please, the standard value for the pressure in Newton per meter square is your 101,325 Newton meter square. Please take note. But if the second value inside that particular question is what is it called, millimeter mercury, then the standard value of pressure will now be 760 millimeter what mercury. Sure you guys get. So these are values, you have to know them. So let me clean this board and then we take questions. At standard temperature and pressure, I don't like this question because they actually start from this STP that I told you about now. So yeah, we know what to do. So at standard temperature and pressure, A certain mass of a gas occupies a volume of 790 centimeter cube. 790 centimeter cube. 790 centimeter cube. Please take it. At standard temperature and pressure. That means that at standard temperature and pressure is telling you that your T1 and your first T and P is standard. Is standard one. And what is your standard one now? At STP, please don't forget, at STP means that your T1 P1 is the standard one. That means your T1 and P1 is the standard one. My T1 is what? 273 Kelvin, and my P1, but for me to know if it is 101325, I would use, or maybe 760, I will use. This one is in millimeter mercury, don't forget. This one Newton per meter square. Let me now check our P2. Let me check from the question. Let me check the unit. It is that unit that I will use to know maybe it's this constant value that I will use or this one. So it says at 790 centimeter cube, find the temperature at which the gas occupies 1000 centimeter cube and has a pressure of 726 millimeter mercury. That means that the second pressure that was given was in millimeter mercury. So this is my constant that I must use, 760 millimeter mercury. Sure you guys get? I hope you guys get, sha. So now let's now continue from where we stopped. So he said occupies a volume of 790. Volume of 790. That's where we stopped though. So our V1 is 790 centimeter. This thing is very simple. Please take note though. Alright, now let's continue. Find the temperature that are looking for. Find the what? The second temperature. Alright, now at which the gas occupies 1000 cm cube. That means my volume 2 is 1000 cm cube. Alright, now and has a pressure of 726 millimeter mercury. So finally my P2 is 726 millimeter mercury. So it was this second P2 that was given that made me understand that it is this my constant here that I will use for the P1. They said at STP. So they started the question that as at STP. That's where I know that no, at STP that means that my T1 and P1 is constant. That's why they started the question with at STP. So as they progress, I was able to bring out this thing progressively across the question. So now looking at this now, what am I going to use? What am I going to use to calculate? Is it gas law? Is this Boyle's law? This one is combining both now. This is PV, my VP and PV, and this is my V1, V2. Wow. This is actually Charles' law. This is Boyle's law. So what we'll do is that we'll combine them. How do I combine? I'll go to general gas law. General gas what? Equation. I will use it. The general gas equation. Now, the general gas equation says P1 V1 over T1 is equals to P2 V2, okay, divided by T2. So you will now put, what is it called? This is your values, the given values, your parameters. Put it into this one, then do your normal math and get your answer. This thing is very simple. You have to solve them under 0.1 seconds. In your JAMB exam on that day. So now your P1 is what? 760 now. Your P1, you put it there. 760 multiplied by your V1. What's your V1? 790. 790. Then divided by your T1. Your T1 is 273. 273 equals to your P2 is what? Where's my P2? 726 millimeter mercury. What's my V2? 1000 naira. T2 is what we are looking for. T2. Then you do your normal math now. Just cross multiply. That is a 760 times 790 times T2 is equals to your 726 times your 1,000 naira times 273. Are you with me? So do your normal math here and tell me your final answer in the section. If you cannot answer this, that means you guys, oh my god. So that's that. So in the next video we'll deal with pressure law, then ideal gas equation, how to calculate it easily, Avogadro's law. If you're having problem with this one, it's the simplest sef. Gay-Lussac's law, wow, the one I love so much. Then Graham's law, the oga. Don't worry, in the next video. So that's surgical medic explanation, and we'll call it a session.